Hello students, today we will start with pellets and its pelletization technique. Now it start with its basic introduction. What is pellets? They are the small free flowing multiparticulate system which are manufactured by agglomeration of fine powders or granules, which includes drugs and its excipient used using appropriate equipment. It requires appropriate equipments. Okay, so what are the advantage of pellets over other dosage forms? First is it has good stability, shape is excellent, dust free rounded shapes, good flow property, the dose can be easy, its compact structure, very low hygroscopicity, high bulk density, dense and uniform structure, narrow particle size distribution, and high active content can be possible, and it can give you control release and optimum shapes for coating. Now the technique is for pelletization is powder layering, solution layering, extrusion, agglomeration, spray congealing and drying, cryo pelletization, and melt spheronization. We will start with one. First is individual powder layering. It is a deposition of successive layer of drug and excipient on the core with the help of binding liquids. One powder is simultaneously and form an envelope or cover on the another layers, which has by the application of binding liquids and dry powders. Right. So layer by layer you are going to apply binding liquids and dry powders. Now it can be possible in conventional coating pan, in which you are going to load a powder, and it is a centrifugal type of bed granulator in which you are going to prepare pellets. A dry powder is loaded in this, and the adjustable rotary disc is there which gives you centrifugation. So because of this, the powder is thrown on the wall, and from the gap between wall and this disc there is a fluidized air is passing out, so it will give you fluidization of the material. So your material is under constant motion, and this nozzle will give you from this nozzle you are having a liquid or binding liquid is spraying, so that there is a constant layering of powder by binding liquids and then again powder until it will give you required amount of shapes. This is the mechanism of formation. See, the droplets are the binding liquids, and the starting core, when you're going to apply constant liquids and dry powder, it forms this type of covers, and ultimately it will give you first layer, and then layer on layer is carrying out. This is called, first is wetting of spraying of solutions, which will be wetting, and after wetting there is a layer formation of the dry powder, and this is the pellet formation, and which will give you, when you take the cross section, it will give you onion type structure of your pellets by this layering, powder layering, right? So here powder and binder, suspension, solution make suitable layering, and thickness layers are applied at the starting grains, and which contains active ingredients, right? So this is about your first system, and here the fluidized bed system is also used, in which similarly here material is fluidized, so it is your tangential spray. Your system is from the bottom, spraying is from the bottom, and sometimes spraying is from the tangential. This is a tangential spraying system which spray from top side. Okay, so here very important part is particle size of the drug in suspension. If the suspension particle size is large, then the amount of binder required to immobilize will be high. So pellets of low potency are produced. Second is technique is extrusion spheronization technique is used. It is a multi-step process which involves dry mixing, wet granulation, extrusion. These are the step-by-step technique in the extrusion spheronization. First is this is a dry mixing of powder, then wet granulation. We have to prepare duff mass, then it is extruded from the extruder, and then spheronize, and then it leads to the drying and then screening. Okay. Now see this, the way of preparation or method. First is powder mix, then addition of some binding agent will give you plastic mass, then you have to use extruder, then the material coming out from the extruders are called extrudates, and then they are the cylindrical shapes, though they spheronized and in the form of wet sphere, and then either they are coated or it may be directly dried. So coated or dried spheres are there. So this is a complete procedure for preparation of pellets. And the variety of extruders: screw fed extruder, gravity fed, and ram fed. These are three types of equipment used to prepare pellets, right? First is axial extruder, in which your material is fed into this chamber and it is perforated from the back. See, it is perforated from the bottom, and when the screw is rotated, there are two types. First is screw fed. Screw fed matlab when you are having a screw, when you rotate the screw, then it pushes the material, right? So in the screw fed, it is of two types. One is axial and second is radial. Axial means when you have this die plate at axial position, and this is die plate at radial position, right? So from back side it will give you material in the form of long cylinders, right? So here it is feeding zone, then when here material is compressed, it is compression zone, and when it comes on the screen, then is extrusion zone. So here also the transport zone is very short, compression zone is little bit higher. So it is material is compressed in this much of area and is extruded from both the sides, so it is called as radial, right? So first is screw extruder, right? Screw extruder mainly, this is a screw fed extruder, and it has two types, axial and radial. Now next is gravity fed. Gravity fed, it is of two types, rotary cylinder and rotary gear. This is rotary cylinder and this is rotary. A is rotary cylinder, second is rotary gear. Here one of the counter rotating cylinder is hollow and one is solid, right? So the solid cylinder will give a pressure to this hollow cylinder, okay? So when it gives a pressure, from these holes your extrudate will come out. Here both the spheres are hollow. Gear cylinders we rotate counter board holes. So this holes will pressurize to the another cylinders and it will give you outsides, okay? So this is two are gravity fed and again repetition, gravity fed and screw fed. Screw fed are of two types, axial and radial. In case of gravity fed, it is of two types, rotary gear and rotary cylinder, okay? Now ram extruder, first is screw extruder, second is ram extruder. Ram, it is probably oldest type. Here it has piston type of structure, and when you push it out, this ram or piston will give you pressure, and from this die it will give you material outside depending upon the rheological property, okay? So these are the, here we have brief description of the techniques used for the extruder techniques used for the pellet formation. You can write any of the technique for preparation, right? Now after extruders coming out, they then send it to the merumerization. Merumerizer matlab spheronizer. From the extruder you are having cylindrical type of the rods, right? So they have to be cutted out and it is send it to the spheronizer and it gives you spherical particles like this, right? So in this you have static cylinder stator and rotating friction. These are the plate depending upon its groove size. See, this is cylindrical coming out from the extruders. They are cylindrical rods, they are cutted, and when it rotates in the spheronizer, it will give this type of rounded structure. Again when you rotate, then it converted into dumbbells, then again it is converted to ellipsoid, and finally it is converted into spheroids. This is the complete procedure of spheronizer. When you add the material from extrudates to this spheronizer, then it will move like this: extrudate cylindrical rods, then it grounded ends with dumbbells with ellipsoid, and this process continues until you rotate your spheronizers, okay? Now next is spherical agglomeration. It is a pelletization process in which powders, on addition of liquid, they are subjected to high temperature, and because of the high temperature, the spherical particles are prepared by rolling or tumbling action. Here, spherical agglomeration can be divided into two types: liquid induced and melt induced. If it is solubilized in liquid, if it is melted at temperature, some temperature, then because of the melting, it forms agglomerates. Okay, so here liquid induced agglomeration, in which during liquid induced agglomeration, liquid is added to the powder before or during agitation steps, and as powder comes in contact with the liquid phase, they form agglomerates or nuclei. Solid bridge, which are driven from the hardening binders or any other dissolved materials within the liquid phase. Now the nuclei forms and they collides with each other and to form a pellets. Okay, so these are agglomeration. Spray drying, here it is again one of the technique of preparation of pellets, here in which air is supplied and material to be sprayed out is pumped through the peristaltic pump, and it is sprayed into the spray drying chamber. Then material is collected at the bottom, and the air which is coming here, it is replaced air which is coming is replaced into the cyclone separator, which will separate out the air, and the particles are collected at the bottom. Here again it is called as spray dried pellets, right, where viscosity is little bit constantly increases until finally almost entire application medium is driven off. Matlab, here drying process is through the stage where